Okay, so today we are actually going to cover the testing of TFA with the new QEMU platform added in OpenCI. So Harrison is going to present and like go through some aspects of it. And towards the end, depending on time available, we wanted to provide some updates on the upcoming LTS release and actually some updates on that. So off to you, Harrison.
Thanks, Vipin. Good afternoon. As Vipin said, my name is Harrison Mutai. I'm a software engineer in OSS working on the Trusted Firmware project. Today, I will be presenting on the recent changes that we made to support QEMU in OpenCI or testing QEMU in OpenCI. The presentation, if I can get it to work. Give me a second. Yeah, there we go. The presentation is split into 3 parts. We'll run for about 25 minutes if all goes to plan. The first part will just be running you through how to actually set up a QEMU test in OpenCI, and then when your test is finished running, navigating the test results. The second part of the presentation will be going over how to reproduce that test setup locally if you need to. Finally, I will just briefly go over some of the changes that we made in the CI scripts in order to provide support to this platform. Just to give some context, we've had support for QEMU and TFA for a while now. And we thought that since QEMU is a software emulator, it would be relatively easy to do some testing on it in TFA CI without the need for a complex hardware setup, just like we do for the FVPs. This would enable us to test newer features. For example, the encrypted FIP feature, which was added a couple of years ago, but still does not have any tests because we don't have support for QEMU in CI. Yes, and the presentation will just conclude with some final remarks and concluding statements. So the first thing I wanted to run you through was if you wanted to run tests in OpenCI, how you would do that. So it's fairly straightforward. The first thing you need to do is navigate to TFA CI Gateway job console in Jenkins. And you do that by opening up the TFA pane in citrustedfirmware.org. And the TFA CI Gateway job should appear under that. Once you've done that, select Build with Parameters and enter QEMU boot test into the test groups input and hit build. Your job should appear in this left menu, and you can monitor it as it runs, but it should take no more than 5 minutes to run the entire QEMU boot test group. Once your test has completed running, TFA CI Gateway produces interactive GUI, which is really helpful because it provides a summary of the individual test results and also provides you with results in a JSON format file. So I've screenshotted what the file looks like. And you may find this useful for post-processing of test results. Internally, we use it in our daily job to analyze all the passes and failures in the job itself. But that's just one of the nicer features. Something else that you can do in this interactive GUI is you can rebuild the entire job by selecting rebuild this job, or you can select a specific test config by ticking in the tick box, and that will provide you with the option to rebuild the selected configuration. The result in the status column is a link to the TFA builder that runs the specific test. So you can access the builder's console directly just by clicking the result. But the little terminal symbol is also a link, and that will take you directly to the console log for that job. The results are retained for about 15 days, which is more than ample time if you need to go back and revisit them at any point. One thing that I just skipped over was when the TFA builder console opens up, that provides you with access to the artifact for that particular test and all of its logs. So Lava populates the results live in the Lava validator website. So you can look at the results live, or you can review them after the test is run. So in the TFA Builder console, the test job ID is a link to the Lava validator platform, which is an interactive platform for reviewing the Lava logs. So as I mentioned, this is available as soon as the test, as soon as the builder submits the job to Lava. I didn't have time to include how you would find it in the console log in real time before the test result is ready. I may do so at the end if I have time, but it's not necessarily important. The other really important thing is the build artifact. As I mentioned, the TFA builder artifacts, the binaries that it runs, the binaries that it uses to run the tests, and also artifacts three sets of logs. These logs contain more or less the same information, and the only difference is there's varying degrees of verbosity. So lava.log just shows the exact log produced by Lava while executing the job submitted in TFA Builder. So that's all of the test setup, the invocation of QEMU, the assertions produced, and finally the environment cleanup. On the other hand, Lava common log is less verbose, as it just shows you the bits that were produced by QEMU. So the actual log output produced by QEMU. And you can see that here, this is the top of the file. And that's the first thing run by QEMU, which is trusted firmware, of course, and the log output produced by trusted firmware. The final log file is a little bit more verbose, but essentially contains the same information as lava.log. And that's the lava-raw.log file, which just has a bit more structured information, which I'm not really sure of the use cases, but I guess it makes it more convenient for post-processing if you do need to do such a thing. Now, supposing you wanted to run the tests locally, we've also provided support for that. And you can do that using this command line. And I'll just explain, I attached this in the mailing list, but I'll explain what each parameter does in more detail further onwards. The only requirements to be able to do this is you need system QEMU for ARC64. Version 4.21 onwards is more than enough. That's what I did the testing with on my machine, but I've tested this with the main line as well, which I think is at 7.2, but I might be wrong, but the main line works as well. So you can run with either versions. And then you of course need trusted firmware A and CI repository sources tagged at v27 onwards. For the existing tests, we don't have any TF-TF tests. So strictly speaking, you don't need TF-TF sources on your local machine. However, the CI script does require that you declare that you have a value for the TF-TF root. And again, this might be something that we need to improve and take out, but you can provide a dummy value that won't affect the actual running of the tests. So the first option is this test run is equals to 1. This basically tells this run local CI script to not spawn any expect instances to track the serial output. And in our case, we don't support expect quite yet, so it's not really helpful. And the other part of that is if we don't enable this, we don't see the output produced by the emulator, which we may want to see, at least in this case, we'd like to see. The second option is this workspace, which just basically tells the script where to build and run the tests from. The other option is the TFA downloads option. And this is just a pointer to a server where the pre-built binaries are retrieved from. And there are a few pre-built binaries that we use in the QEMU tests. So we have the kernel, of course, EDK2, and the root file system, and all of these are retrieved from this server. If you wanted to override this value and provide your own binaries, you could. The only thing I would say is because the paths are all relative to the paths are all relative, you need to try and keep the same paths in your in whatever directory you keep your binaries in. This option should probably be removed as well, and because it's an OpenCI parameter, it basically tells OpenCI where the scratch and tool area is, but it's not really useful for local runs. But I just thought it's important to highlight that if you will be running it. I've skipped over this TF root and TF-TF root because I think it should be fairly self-explanatory. The final option is just the test case that we'd like to run, and you provide that through the test groups option. And now with all of those, I can demonstrate just how to run them on your machine. So this first part is just providing the path to the TF-ACI scripts. And then I've just copied the command that I showed you previously. And now this is the TF-ACI scripts running. And you may or not be familiar with this. But what it's doing is downloading or installing the Python libraries that it needs to build TFA. And now it's building TFA, or at least the debug build of TFA. Downloading UEFI or EDK2 rather, or the pre-built binary for EDK2, fetching the kernel, the root file system, and then building the release, building TFA in release mode. Compile should finish compiling in a second and start booting QEMU. There we go. So it's launched QEMU, booted very quickly. You probably didn't have a chance to catch it. It's in the kernel.
So quick question while this is running, right? What's the requirement of the environment? Like, do you have a container or something, or are you just saying take any Linux box and make sure QEMU Art64 is there and that's it?
Could you ask that again? Sorry, I didn't quite get the question.
So what's the requirement? Can I run what you just ran on my Linux box with just an Ubuntu, for example, or
yeah,
do you have the requirements on the environment?
You can run this just on your, the only requirement that I mentioned above is you need to have the TFA and CI scripts repository on your host machine or on your machine. But other than that, I think it should run directly on your machine.
Okay, nice, thanks. Does this also include when you say TFA, does this also include the Hafnium test, for example, or this is just purely TFA booting Linux directly?
This is just TFA booting Linux directly.
Okay, thanks.
And just at the very end there, just to demonstrate that we are at the Linux prompt, just print out the root directory. And yeah, so that's if you want to run it locally. Now I'd like to just briefly go over some of the changes that we made in the CI scripts to allow this to work. This may be of interest if you want to have your platform, well, make some changes for your own platform. Before I get into the details, though, I thought it was important just to give some context about the CI architecture. So our CI consists of a build and run phase. The build phase is responsible for downloading and generating all the resources required to run the tests. So that's the TFA binaries, the BL1, BL2, as well as the external resources or dependencies that we may have. Whereas the run phase executes the output of the build phase. And that execution can happen on a local machine as we've done, or in Lava. The information about that the build phase uses to produce those binaries is encoded in this test configuration. So I've just given an example of a test configuration here, and I just keep this in mind, but I'll explain what the test configuration does in a second. So the test configuration, if you're not aware, is a string that consists of two parts. So on the left-hand side of the colon, there's the build configuration, which is just a plain text file in the CI scripts folder, in the tfconfig and tf-tfconfig paths of the CI scripts repository, which tell the build scripts how to compile TFA and tf-tf. So to give you an example, above here, we had test configuration, QEMU default, QEMU Linux rootfs, zip UEFI vert. So the build configuration in this case would be QEMU default, and we don't have a tf-tf build configuration. And so the build script would look in tfconfig and identify the file QEMU default and build TFA with these options. The run configuration, on the other hand, is the right-hand side of the colon, and this specifies the steps necessary to set up the test environment. It's completely decoupled from the build configuration, but it typically involves choosing a non-secure payload. This means picking the image that trusted firmware hands over non-secure execution to. For instance, a non-secure bootloader that further boots a rich OS, in this case, EDK2, or downloading optional pre-built binaries for special configurations like secure OS images, or generating a firmware image package. So there's a variety of things you can modify the build phase with using these run configurations. And so knowing this, we outlined some steps to get a working QEMU set up in CI. And the first thing that we decided was we simply just needed to figure out how to boot QEMU from TFA to the Linux shell on a local machine. And then once we figured out how to do that, we'd need to figure out how to automate the build steps and fetching of pre-built resources so that this could be reproduced without any user intervention. And then based off of that, set up a reproducible test environment in CI, after which you could figure out how to automate job submission. So for the first part, our public documentation has some details on how to boot the kernel with TFA and QEMU. So I thought it would be fairly straightforward and maybe take a few hours, a day at max. And in the end, it proved to be a lot more challenging than I had initially anticipated. I realized that the documentation hadn't moved in about 2 years, and there was every chance that it hadn't kept up with changes in the firmware, or perhaps things in EDK2 had changed that meant that the steps that had been outlined originally just wouldn't work anymore. So I started digging around, speaking to folks internally. I spoke to Andre Chavara in the Linux kernel team, who proved really helpful. He's obviously got lots of kernel experience, but he also had links in the QEMU community, including to Peter Maydal, who's the main maintainer for ARC64 in QEMU. So with him, we were able to eventually come to a command line that we could use to launch a QEMU guest. And this command line combines the firmware-based and kernel shortcut approaches for launching a QEMU model, or a QEMU guest rather. And so in order to do this, we created a boot ROM consisting of BL1 and a firmware image package compiled with EDK2 as BL33. And combining these two options, this BIOS and kernel option, means that QEMU, when QEMU is launched, it loads the kernel into DRAM and puts that information into the firmware config device. The boot ROM is then responsible for providing the kernel with the device tree and performing any platform setup, which would be done by QEMU with the kernel shortcut alone. For the external resources, we just use the default ARC64 configurations. So that's the kernel, and then we reuse the root file system that is used by Juno. We tried to experiment with U-boot to see if we could get that working as well. But it turned out to be not as straightforward as EDK2, since it required some extra patches that weren't already in the mainline. Excuse me. So as I was saying, we tried to experiment with U-boot, but that didn't really work out. And since we needed some extra patches, we decided to set that aside, since we'd already achieved the thing that we set out to achieve from the get-go, which was just booting TFA with booting Linux from TFA. So the next step was automating the build steps and fetching of pre-built resources. As I mentioned, there was four binaries that we identified we needed in our test framework: the kernel, EDK2, the root file system, and of course the boot ROM that we made manually. We quickly realized that some parts of this, it wasn't really possible to compile at runtime. If we were to compile the kernel or EDK2 at runtime, it would take 20 minutes or more in OpenCI. So that wasn't really an option. So we quickly settled on placing that in a file server somewhere that we could access and pull from when running the tests. And then, of course, we would have to build TFA from source if we needed to test that. So I introduced 3 fragments. The first fragment, QEMU-linux.rootfs, is really simple. All it does is it fetches and archives the kernel and root file system. And there's already several utilities available in the CI scripts repository that you can reuse to do this kind of thing. So that was fairly straightforward, a trivial one-line addition. And then I also added QEMU-vip.uefi, which is a little bit more interesting, but again, just reusing a lot of the scripts that we have already. And what that did was fetch EDK2 or a pre-built EDK2 and build the FIP with it as BL33. The last fragment, QEMU-BERT, is a little bit more interesting. And that's because we set up we added the compilation of the boot ROM, or creating the boot ROM image that we provide to QEMU with the BIOS option. Again, it's a lot of it is using utilities that we had, but we just added a simple utility to combine BL1, concatenate the FIP image to BL1, and artifact that binary. So at this stage, we've figured out how to reproduce compiling TFA and all the sources that we need, and creating an image that we can boot QEMU with. The next step was figuring out how to set up a reproducible test environment in CI. So I initially thought I would use the same approach as what was used what is used for the FVPs. For the FVPs, what we have is containers that contain containers with binaries for the FVPs that we run at test time. However, I had a look at the device types supported by Lava, And as it turns out, they had a QEMU device already in their device list of supported device types. Now, this is really convenient because it provides a generic environment for one, but also it provides a set of actions that we can reuse without having to implement ourselves. And so it just made sense to use what was provided by Lava. And if this is something you're considering, it does make sense to go and just have a look at what platforms they do have and see if you can just reuse one of theirs. They also have some documentation on if you want to add a platform to their testing infrastructure, which is a lot easier if it's just an emulated platform. So for the QEMU device type, they have a set of actions that you can reuse. So there's 3 actions. There's the boot action, which tells Lava to boot the device and check prompts to see whether the device is booted correctly. There's a deploy action, which tells Lava to download files to boot the device and prepare an overlay of files to run the test action. And then there's a test action, which you can use to provide Lava a repository with test cases and then tell it to run those test cases on the device you'd like to test. For our particular use case, the boot action was more than sufficient, and it was really helpful because it constructs the entire pipeline for you, and you can provide it with a user with a prompt to expect when the system is booted successfully, and it fails if it doesn't find this prompt. So this screenshot just shows you the logs in the console I pointed to earlier that show the kind of checks that Lava just does by default when you add a boot action. Before I continue, does anyone have any questions? Okay, I'm almost done. So the last step was figuring out how to automate job submission to Lava. And again, there's already a precedent for this, so it was just natural to follow whatever the precedent was. So Lava has 3 ways that you can submit a job. You can use either the command line tool or the XML RPC API or its web UI. In the TFA builder, we already use the XML RPC API to submit jobs to Lava. So naturally, that's the approach that there's not really any modifications I had to make there. But for all Lava jobs, you have to define a configuration, which is defined in a YAML format. And the job configuration basically defines what software should be deployed on the device under test, in this case QEMU, and what actions should be performed there, and in this case booting. So I created a simple job template, a simple template job configuration for boot tests, and added some scripts, or added some functionality in the scripts to expand those templates. So I've just shown us a simple snippet. It's the script, the template is not much longer than this, but this is just the first half of the template. And then there is only one function that handles the expansion of this template, but showing the steps to the actual output that we expect at the end. And so you can see here, from the template, we've added a machine type, the CPU type, and then the extra options that we'd like to add to them. We'd like to invoke QEMU with. And so with that, I guess it's that's where we are. That's where we stand at the moment. We aren't using QEMU to gate patch submission, but in the long term, we do envision adding it to L1 and L2 tests, at least as soon as we're confident that the tests are stable. But there are also still quite a few gaps that need to be filled. So I just realized there's a typo there, but this isn't a substantive list, but it's just some of the things I thought of when making the presentation. There's still obviously a gap in the expect script support. it would be good at some point to have that added. We also still need to add some test configurations to handle measured boot. I've spoken to, I think it was Zhao, and he was mentioning there's some discussions, at least in Hafnium, about adding tests. But Opti still requires some tests as well. And at some point, I think it would be good to add another bootloader, another non-secure bootloader as well. And so if you're interested or keen to make it better, all contributions are welcome. And we're also looking for some help maintaining the infrastructure. So if this is of interest, please don't hesitate to get in touch to either myself, Joanna, or Sandrine, or anyone on the team. And we can provide you with whatever details you may need to do so. Other than that, thank you so much for attending this presentation. I hope it's been informative. If you have any questions, please don't hesitate to get in touch. Thank you.
Hey, Harrison, Varun here. So I just had a couple of questions. I think when you started, you showed you just traversed through a UI to start all these QEMU jobs. Just wanted to check if there are any permissions or any restrictions to access that UI, or is that open to everybody in the TFA mailing list?
That's a really good question. I believe I needed to get permissions to, I think you have to request permission to get access to that platform. I'm not 100% sure, but if I recall correctly, at least when I first started working on this, I did have to get permission.
I see. Okay, so so then people need to ask for permission. Would it be just contact someone on the mailing list, or?
Yeah, it would be as simple as that. I think Joanna or anyone on the team would be able to get you that access.
I see. And I also saw that you entered the test group names when you started or fired the test. So I'm sure you know already what test groups are available, but for people like me who don't know the exact names of the test groups, is there a simple way to figure out the names so that we can also use those?
Oh yes. So I'm not sure if do you have access to the CI repository?
Yeah.
So if you just ls, there's a folder called there's a group folder.
Okay.
And so in the group folder, that provides you with the top level directories are the groups, and then they have plain text files in those directories that provide you with the specific test configurations.
I see. Okay, thank you.
I don't know if it would be helpful to pull up a terminal window. If I could, I think I'd have to exit the PowerPoint. But I can send you something offline if that's helpful.
Sure. If it is not too much work, could you add these two answers or points to your slides before you send them out?
Okay, sure. Yeah, let me take a note of that.
Thank you.
So does anyone else have any questions on this?
Yeah, Harrison, just to add on what you said, like, yeah, this test group you created is running every day right now as a part of TF Daily, as everybody can see it from the slide. Just to highlight if someone missed it, right? So this test, means whatever the contribution Harrison did it, like, yeah, the test group addition, this test group are every day getting tested, and we will be happy if somebody contribute in that test group, and we'll add some more test cases over there. And even Harrison highlighted the major boot support and some few more things we will be planning to add in the due course, but if someone want to really pitch in, they can really create some test configuration and add it as a part of that group. Yeah, that will be helpful. Yeah, thanks.
Okay, so I assume there is no more questions. So thanks, Harrison, for the presentation.
Thanks, Vipin.
So any other topics for discussion? If not, I have a quick update on the LTS. Okay, so something that we wanted to update the LTS maintainers. We created 4 different branches of the trusted firmware v2.8 release. The 4 repos that are actually having the branches, as you can see, are the trusted firmware, the trusted firmware test case, the CI scripts, and the TFA job config. So all these branches are created in preparation for the first release that we are targeting in Feb. So at the moment, the plan is actually to have a LTS release candidate by first week of Feb. And a couple of weeks later, we will have the first LTS release. So there is also a tech forum that we are planning in Jan 23. So before we actually do the first LTS release candidate tag, that will kind of explain the process that we follow for the LTS release. And then we will actually be publishing once we have the tech forum, and actually we will also be like publishing the proposed dates to the mailing list once we get close. At the moment, the plan is actually to add just errata and security patches on top of these LTS branches for any like updates to the LTS branch. So the first LTS release will be potentially the v2.8 release with any updates on errata and security. So this is actually just something I just wanted to update. So Varun, do you want to add anything else?
Hi. Yeah. So just also wanted to say that we are planning to use the newly announced LTS mailing list more. I think there hasn't been a lot of traffic on that mailing list, but we hope to get an announcement going, and then once that goes on, once that announcement is made, then we plan to publish meeting notes and then any other discussions that the maintainers are having, to make it really open to everybody and not something that's happening behind closed doors. Another effort that I also wanted to start, and we discussed with the other maintainers, is the patches that we will look at from the 2.8 branch. So just a short description of what patches were considered or rejected, and then the reason for that would be somewhere on the wiki or some global document or some place, so that the logistics have to be still worked out. But that information would also be made public so that people can, look at what has happened to a certain patch and then provide comments. If there is a case to be made that a certain patch needs to be accepted, if it was earlier rejected, or any other comments, then just to start that conversation. So those are the other activities that are also happening in parallel.
So any questions? Okay. So thanks everyone for joining, and yeah, actually we are done for today.
All right. Thanks. Bye.
Thank you. Bye.
Thank you.